knowledge that you already taught in thermodynamics 1 has to be used in this course. So because this is the part of your thermodynamics, because thermodynamics is the one course. So in our curriculum, we divide into two parts so that student can easily understand the thermodynamics. Okay, so this is the thermodynamics too. So I will just go through the outline of this course, which we have to go through during so the course outline for this one is that we will more focus on in this course is the first is the heat engines, and in the heat engines we will come across the Carnot Vapor cycle, Rankine cycle, reheat the Rankine cycle, Otto and diesel cycle. These all are the heat engine. So first part is only focus on the heat engines. Okay, so the second part will be the compressible flows. Okay, that will come across the stagnation, critical state, property changes in the varying area ducts and nozzles. Okay, nozzle efficiency and supersaturation. Then there will be a chemical reaction that will be more related to the IC engines, the basic concept of reacting and non-reacting system, fuel and combustion processes, theoretical and actual combustion processes. So we will come across something that will related to the IC engine, so you can better understand the application of thermodynamics too. Then there will be a portion of turbo machinery. Turbo machinery, that will be the types and of turbines, impulse turbine, reaction turbine. So how to build the velocity diagrams for the impulse turbines and reaction turbines, velocity compounding, pressure compounding. So these sort of things. Okay, so but first this lecture, because this is the introduction lecture, so I will not go directly to the lectures of the heat engine and power cycle. First, I will focus on the review of thermodynamics 1, because that is more important first, so that you have the revision for the thermodynamics 1 course. Okay, so for this, I will just give you a revision for thermodynamics 1. So that will be a basic concept, but I hope that you already understand, you all of them understand well the thermodynamics concept, but I will try to just revise it quickly, so that before starting this course, you already have something in your mind that these are some basic thermodynamics concepts. Okay, because whatever in the thermodynamics too, you will more focus on the applied problems. Okay, so in the applied problems, you already have the hands-on knowledge of the thermodynamics, basic thermodynamics. So outline for this revision is that system, surrounding states, you already know this type of things. I will just quickly revise it. Okay, so these are some outline of the presentation. Okay, so you already know that what is meant by thermodynamics. Thermodynamics deal with two things, that is the heat and power. So whenever we combine these two things, or we can study independently heat and power generation processes, so it come under the domain of thermodynamics. Okay, and then in the thermodynamics, more importantly, we study energy and energy transformation processes. Okay, that will be maybe your power generation process, it will be a refrigeration process, it may be a relationship among properties of the matters. So all this come under the domain of thermodynamics. And whenever we are talking about thermodynamics, you already know that the main concept for the thermodynamic system starts from the systems and surrounding. Okay, so any thermodynamic system, whenever we use the term thermodynamic system, the first thing is your system. What is your system? For example, if I say that my laptop is one of thermodynamic system, so I will consider my laptop as a whole as a thermodynamic system, is a system. But if I consider that, for example, if I want that specific part of my laptop, for example, it will be some sort of keyboard. Okay, so then I will consider my keyboard as a system. And whenever we are analyzing the thermodynamic system, we have to draw the boundary. Okay, so what the boundary can do is boundary just try to so we can just draw the imaginary boundary. Okay, so in which the area you are interested in. For example, if I am interested in to go for the thermodynamic analysis of that room, okay, of any room, so I will draw first the boundary, where the boundaries are, okay, from where there will be a mass interaction or there is an energy interaction. So that will be more important, because it is on you that where you want to build your boundary. So it is your interest. Okay, then there will be a surrounding, anything which is, so system you can just define as the quantity of the matter or region in the space chosen for your study. Okay, so it is your study. Okay, that you have to define the system. Surrounding, mass or region outside the system. Okay, so any mass or region that is just outside the system is called the system surrounding. Okay, then there will be boundary. Boundary is a real imaginary surface that separates the system from the surroundings. Okay, so these are three important things whenever you want to analyze your system, and we can use these terms frequently in our thermodynamics 2 courses as well. Okay, then there will be a term as a boundary. Okay, so boundary, there will be 3 types of boundaries. Okay, first we can used as a fixed and movable. Okay, for example, if you have a what we call as a piston and cylinder arrangement, okay, so we can assume it will be a fixed boundary as well and as a movable boundary as well. So okay, so it's depend on you. And second is that it may be possible that your boundary is shared by both of the system and surrounding. Okay, and then we can assume that there was a no thickness and no mass and volume of your boundary. Okay, then you already know this term, that is the closed system. The closed system we can define as that there will be a no mass exchange across the boundary, but there will be an energy exchange across the boundary. So it will be called as a closed system. Okay, and the mass is the constant. Okay, and it is also known as a control mass. Then second is the closed system with moving boundaries. Okay, so there will be example that there is a piston cylinder arrangement, and inside there in the first arrangement, if okay, I will just try to on my pointer. Okay, so on the first side, you can see that there will be a gas and there will be a 2 kg of the gas, and the volume of the gas is 1 meter cube. Okay, but in the second one, when we move the boundary, the volume increase, but the gas is 2 kg. Okay, so this is the example of closed system with moving boundary. Okay, so you can also have the knowledge about these. Then there will be a term as an isolated system. Isolated system, what we call is in which the mass is constant and energy is constant, and there will be a no exchange of mass across the boundary, and there will be a no exchange of energy also. Okay, so that term is called as an isolated system. Okay, and the term is called open system. In open system, both mass and energy can exchange from the boundary of your system, and it is called the open system. Okay, and it is also called a control volume. And the example of your open system is water heater, car radiators, turbine, compressor, okay, and any type of refrigerator which you commonly use as a home appliances. Okay, then the boundary of the open system is also known as controlled surface. Okay, so whenever you are dealing with the thermodynamic system, we deal with the real boundary and imaginary boundary. Okay, so you have to build some boundaries in which you can show that there will be something, for example, there will be a mass in, there will be a mass out. So you have to draw something like this. Okay, so any thermodynamic system we represent in terms of boundaries. Then you already, Gigi.